Hello YouTube, just a quick video. I'm going to go through the install process for a CB40 installation and the pinouts into a GE A3-5825B, the dual board Cybernet chassis. This also correlates back to the Cybernet Mark I boards as well, which many other companies share the same product. So I'll turn you around. Thank you. Okay, what is a CB40? A CB40 is a synthesized board which suits many different types of PLLs. It's a drop-in product into most radios. This is the version 3, but the 2-digit display only. This unit has the provision for OLED or a twin LED display, and there is another version that takes 3. Alright, so for the purposes of today's radio, we're going to do a standard installation. It's in a GEB model that I have been working on. And there's the top board. The caps are done, so it's progressed since the last video. Alright, so the product itself. The product itself has, let's see, you've got your headers for the PLL, which are all color-coded. You have a 5kc or 10kc switch option, a TX detect hookup, which I hooked that up to the TX light. Then you have your header for the encoder, and I've just installed the encoder there. And then you have this header for the 2-digit LED display, or you can use the OLED, and they actually work simultaneously if you want to install them both. But for the purpose of this radio, the owner wants it looking standard. This is your voltage for power, which on the GE I take the power off the orange and the wire to the old channel display. And then you have the scan feature here, which you only need to use the number 1, which is the signal wire, and you take that to the positive side. I'm actually going to use the ground. I'm going to put that on the negative side of the meter as well. All right, so that's the product. And as you can see, there's a lot. It's a busy device. However, once you start going through and allocating the wires where they go, it starts to get a bit simpler. All right, so how do you hook it up? All right, so as you know from my previous videos, neatness is a very important thing. A lot of people hook it up their ways and directly to the board. A lot of people hook up to here, or they flip the board and they hook up directly to here and removing the header pins. I don't do that. I want everything to be able to be reversible and clip together so that it's serviceable. All right. So the way I've got this set up, I removed the pins and then joined them onto the wires. The wires are in the same color sequence as the original color code. The only thing you don't use is the gray and the white on the end, as the grey and white get spliced into another push together connector that I've made, and that joins into here, which goes through a hole in the board which I've drilled, and that connects to the main switch side to get the extra or the expansion of the CB40. Okay, so the Razer Radio's VCO has been installed. I've upped the size of the capacitor to a 25 volt Nikon 2200 UF. I've installed a chip holder, and the main reason for that is to avoid any track damage. As the tracks on these or any of these radios probably only good for 2 desolderings. So I've desoldered this once to remove the chip so that no heat during the modification process would make the chip fail. And before, I'm sure people have said they've never had a chip fail. Well, I've had 2 in the last 12 months, and it was due to poor soldering techniques when it came to heat. Okay, so the system that I have for desoldering is you'll heat one up, desolder, heat the other up, desolder, opposing sides, just like you're doing up a car head, and you're distributing the heat over the whole board. All right, I think I mentioned this in the last one. All right, so I'm going to show you a picture of the other GE which I have here. This is my reference one, which I did, and that's got the OLED display here, which has all detail come up on it. So it's a bit different to this one, and there's a video on this one on my channel. All right, so this is the O2a chip. So I mentioned here that I've drilled a hole in the board for neatness. 3 wires come up through. This is your 510 kc switch. So that's what I've put the blue wire to. And then you have grey and white there, here and here. The tracks that you need to cut are the ones behind this here. One there, isolating this pin, isolating this track totally, isolating this track. And this track you need to do a 90-degree bend on and isolate this pad totally, which is the ground side of the the positive side of the capacitor underneath. So that's the capacitor that goes from there to there. All right, so this one here, you have to create this pad. So you have to neatly remove the green paste, solder it, and then create your connection. There are many other ways of doing this. Some people like to use just metal, run it from there to there, to there, to there. I tend to, this is a technique that I've used on a couple of these now. You see that? It's very neat. And then at the end of it, I've used the Gorilla Tape to secure the cable and cable ties on both sides of the board so that you can't put any stress on these wires. Okay, I'll go in closer. All right. Now I've actually had this, as you know, the PLL out. I've put it back in, and the soldering is, I think it's quite a high standard. All right, so what are we going to do now? All right, so the next step was to take the encoder. Oh, and by the way, that's my work from yesterday. I put a bit of green highlighter on it, just to dull it down a bit. Okay, so the next step is to take the encoder and to put that into the radio. So what I had to do here was remove the 18-channel display and install that encoder into the back of the radio. Now, as you can see, there's a big hole here. So what I do with these is, using the original screws, I make up a backing plate, screw the backing plate in, and that allows me to mount the encoder. Okay. All right, so the next stage is to take the LED and install the LED in that window, but we need to do some mods to the holder just on this edge and this edge. So I'm just going to heat up the soldering iron and do a bit of work on that. Okay, it's a bit more refinement to go on, but you get the idea. And it's quite actually a good system. The manufacturer 3D prints the holder, and then all you do with the holder, as you can see by the shape of it, it's very well made. I just melt it to fit in between the LEDs with a soldering iron until I get the desired effect. It's all very, very nice. All right, so on the back of these you have your connection points, which you use this one. All you need to do is make sure that you connect the cable. Each cable has a ground wire to the right pin. On the case of the twin LED, it is actually manufacturer has on the header, it's a twisted pair. So as you can see here, the yellow and the grey are crossed on this header side, and then on this side it's a straight fit. So you just need to be very careful, and again, earth goes on one side and earth to the earth, and then you're right. Okay, so where am I going to fit the CB40 in the radio? Well, if we take this GE, where I remove the channel selector, I sit the board vertically and use double-sided tape. And again, it's the Gorilla tape. And you can see here this fitting here, which again goes through to the PLL through the board there, and that allows to disconnect. So with this fitting, which is just as manufacturers, you can quick disconnect. The same with that one. It makes for a very professional install. So be proud of your work. All right, so when I've got more, I'll show more. But that's how you install the CB40 in a twin board GE O2a chip. You do not have to run the 510kc. You need to run these. This is your expansion section, and then you choose via the menu to have it just standard 40 or expanded. All right, I'm Paul. Please like and subscribe. Much appreciated. And this is step 3 in this restoration process of this radio. So now we get back to assembly. Thank you very much for watching. Comment, like and subscribe. I would appreciate it.